Hey guys, perfect and perfect. Sure. So I'm gonna right now we are talking about infinite series, ne? Yeah. So smaller than a recap of what we have done so far. We spoke about sequences, ne? And of course, sequences is just a fancy way of saying patterns. We spoke about arithmetic, geometric. Oh, we also spoke about quadratic as well. So yeah. Then we moved from a sequence to a series. And what differentiates a sequence and a series is that a sequence is just a pattern with commas. Yeah, yeah. And then when it only becomes a sequence becomes a series if now we start to add the consecutive terms. Not necessarily the consecutive terms, but all the terms from a particular number to a particular number, usually from 1 to a particular number, right? And when we are adding when you are adding the numbers in your sequence, you are adding them from n equals to 1 to n equals to a particular number. We call that finite series. We spoke about geometric finite and we spoke about finite arithmetic as well, right? Which is cool. But there are cases now where we don't want to add to a particular number, but we want to add these numbers forever. Yeah. So it's like now we are making the value of n to be as big as possible, right? Not just as big as possible, but we are increasing n infinitely. English. Yeah. We are adding n, bro. Like, no, we are not adding n. We are adding these numbers in our sequence name. We are adding all of them, but for n equals to any number, like, yeah, bro. We are adding, bro. We don't stop, man. We don't stop. Yeah, because usually, yeah. Take for an example, arithmetic. Yeah, arithmetic, it continues forever unless in the question it was stated that or maybe you had the last value and there was a full stop afterwards, but usually, like, it's just continuous, right? It continues. Imagine if we would add all the values in an arithmetic series, or there's the better way of actually putting it. Imagine if we would evaluate the arithmetic series value. Yeah, because arithmetic series is just an addition of these values, which are, which were taken from an arithmetic sequence. So imagine if we add all of them, right? Because and it goes forever, yeah. So imagine if we'd add, and I ask you, what is the, sum to infinity of that? What's the answer? There isn't. I mean, there is, but I don't know what it is, but there isn't. Because it's going to be a big number, or a very small number. It will be a big number if you had an increasing arithmetic, and it will be a very small number if you have a decreasing arithmetic. You see? So, we have already established now that when you add or when you evaluate the value of a series, there is a possibility of you getting a particular value. Yes. There's a possibility of you getting a particular value. Also, there is a very high possibility of you not getting any value at all, because, hey, bro, yeah, good example, it would be like, good example is this one. But you see, if death, this thing called death didn't exist, ne? And also under the assumption that age is still important, do you think we'd really care about how old someone is? we won't even bother to memorize the number that this guy has been, living for over a million years, bro. Perhaps that's how we would say it, but we won't actually bother ourselves to care with the exact number. Yeah, I don't know, but yeah, we won't care, like, because we will never die. Why it? You know what I'm saying? Like, it doesn't. It's not important, yeah, right? Because you're gonna live forever. Time does not. Yeah, you exist outside outside time. Cause bro, like yeah. So I think that's so basically we're just adding. I mean, cause your age keeps increasing by one each year. But now imagine, like, if you can, you will never die, bro. Like, imagine if you live forever, man. Like, there'll be a point where you won't even care how old you are. You will just know that you are old, right? And in terms of how long you've been here for, it would be just, I've been here for thousands and thousands of years, or millions and millions of years, or billions and billions of years, right? But you care for the exact number. uh, just think about it, bro. Yeah. So let me come to what we are talking about. We are talking about infinite series, where you have a series and you're adding up until forever, right? And yeah, so you have already established now that there's a possibility of you not getting to any value at all. I mean, this, like, the finding the right way to mathematically say this, because you won't get to a particular value, but the value which you won't get to any value, bro. Another perfect example is, like, imagine you're driving, the vehicle that you're using never runs out of petrol, so you will never need to stop for petrol or to pump your tires, right? So yeah, it will just, so long as you are, you can drive, bro, like, it will drive. So now imagine if there's a road that never ends. Will you ever get to a point where you're like, yeah, here we have arrived? Yeah. I mean, and you can't even say this is a halfway. Or you can't say this is halfway, because you don't know, like, how far, like, that the journey doesn't end. So, like, this road, it doesn't end. It goes up to infinity, positive infinity. But yeah, it's just crazy. Let's talk about this. So when you are now finding your sum to infinity, there are two things that we're going to talk about. It's convergence, and there's divergence. Yeah, we will talk about convergence and divergence, right? So to say that a number diverges is if a number doesn't approaches any value at all. We haven't spoken about a case where a series approaches a particular value, so we will talk about that in a minute. But here we see that okay, let's make an example. Say you're trying to find sum to infinity, right, which will be n equals to 1. Say we are using 2n. Yeah, 2n is fine. Come on, positive infinity, yeah. So here, the answer is 2 plus 4 plus 8 plus 16 plus 32, right? Bro, bro, it continues, man. It continues because it's set to infinity, right? There's no way I can even write 1,000, couple of hundreds and tens. No, it continues, right? And as you can see that each value, or the value that follows, the next value is always bigger than the previous value, right? Yeah, the next value is always bigger than the previous value, right? So that being the case, it becomes even more clear that we are not going to approach any value, because as the value of n increases, the term value of that n is getting bigger, and the summation overall gets bigger. The summation gets bigger. You understand, yeah? Yeah, so there's nothing we can do here. There's not even a formula of evaluating this, right? But look at this one. Look at this one. Of course, you know laws of exponents now. I don't have to explain to simple. Um this is the same thing as having 1 over 2 to the power of n. I don't have to explain that to you because you master laws of exponents, right? So I'll get rid of this, yeah? I'll get rid of that. And then you know the answer here is 1 over 2, 1 over 4, 1 over 8, 1 over 16, right? 1 over 32, right? Plus, yeah? But now, I want you to see something, eh? I want you to see something. So let's press, okay. So I'll just say 2 to the power of negative 1, right? It's 1 over 2. I wonder how I can make, but it's fine. Let me see. Ah, it's fine. 1 over 2, right? Let's see what's this. Okay. Yeah, that's 1 over 2, right? 1 over 4. Aye, man, 1 over 2.5. Man, yes, it is 1 over 4, but like 0.25. Just look at the decimal values. I want you to focus on the decimal values né, to see as we increase the value of n, what happens. Né? 3, 0.12, and 4, 0.0. The previous one was 0.12, now it's 0.0. Now let me go crazy, right? 100. Né? Look, I have a minus, right? And as you can see, this is a very, very, very small number, smaller than 0. No. It's not smaller than 0, but it's very, 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 very close to 0. Remember when we talk about 7.5 multiplied by 10 to the power of negative 5, right? It's the same thing as having 0.00001, 2, 3, 4, 1, 2, 3, 4, 5, 7, 5. So how am I? Wait, 1, 2, 3, 4, 5, 7, 5. Yeah, this is basically the value. You see this value? It's quite close to it's close to what? Very, 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 very close to 0. In fact, when we round off this value to 3 decimal places, it's 0. 2 decimal places, 0. 1 decimal place, 0. Right? Yeah. So look at it. It's 7 point. Okay, so now forget about these values. Let's focus here. Right? 10 minus, yeah? 10 to the power of minus, yeah? Let's increase that to 1,000. Let's see. It's now, remember it was 31 minus 31. It's now minus 3, right? Let me show you something. You see? Here's the value. Let me see. So yeah, this is where we are. Minus, let me make it 100,000. If I make it 100,000, we get 1 point. You see? So now it's like 0.0000. So you're gonna have like, I think about 30,000 zeros before you actually write this number. You see? So it's like 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 up until like 30,102 zeros. You're gonna have 30,102 zeros, and then after the 30,102 0, yeah, after that 0, then you write 1, and then 000, then 99889 continues. But you see the value, it's very, very small. It's very, very small. And now when we talk about this, right, you realize that here as we increase n here, the term numbers, they get closer to 0, right? Good example is, if I have n squared plus 1 divided by 100. Now, if I have this thing, and then I try to evaluate the value of this, as I increase the value of n, this thing, let me call it k equals to, if I increase n, k is going to increase always and forever. I increase n, k increases, and yeah, and there's no particular value that k will get to or approach, right? But now if I have 100 over n, right, every time I increase the value of n, k, it decreases, and you would see that there's a point where k is going to be 0, right? Let's test it out, right? Of course, like, I mean, if I make it 2, bro, you get 50. You make it 50, you get 2. You make it 10,000, we're getting 0.0. Let's make it a million, million 0.0001, right? How about 100 million? Look, you have, and as we keep on increasing value of n, the k becomes smaller and smaller and smaller every time. K, right, it becomes smaller and smaller and smaller every time, right? And remember, for the previous example, okay, here we have 100 multiplied by n to the power of -1, or multiplied by 1 over n, right? And yeah, and on the previous example, let's say that is m, right, where we had n squared plus 1 over 100. In this case, look at, what am I trying to say, bro? So the difference between this, even if I make this n, even if I make it n over 100, as I increase n, m will always increase. Like, it will get bigger and bigger and bigger and bigger. It will not get to every particular value. But you see here, as we increase n, k approaches 0, because we get closer and closer and closer to 0. Right, so that's the case. Right. So for here, we would say that this k, it converges, but it converges to 0 because we are approaching 0. And then for m, this m, it diverges because we are not getting closer to any value at all. You understand? That's the concept of convergence and divergence. But now, because we're talking about series, we have, remember the formula, we had two formulas. We were like, sum to infinity, no, Sn is equals to, sorry for that, is equals to a 1 minus, right, 1 minus, and then we had also Sn equals to r minus, right? So we had these two formulas, and we said here we're going to use it. Of course, for both of them, r cannot be 1, so I won't talk about that. But we did say that here, that is for if r is smaller than 1, and here that is if r is bigger than 1, right? So here, right, I can show you. Imagine r is bigger than 1, r is bigger than 1, and here we are raising that r to the power of 1. Bro, this minus 1, they have no effect on what I'm gonna say, because as we increase n, r is going to always get bigger and bigger and bigger and bigger, right? So this man converges, yeah, this formula, it converges. The one that could possibly diverge is on this one, right? So let me remove this man. So a possible formula to have convergence is this one, right? And but also convergence divergence can happen here if say r is smaller than -1, right? If because in this case, if r is smaller than -1, what's going to happen is that r is going to always get smaller and 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 smaller up until negative infinity. right? So there will, as we increase the value of n, we'll be getting closer and closer and closer to negative infinity, which is not a value at all. Right? I mean, there are people who've been debating that infinity and negative infinity is a value, but nah. Yeah. So the convergence now, it only happens if and only if, right? If and only if you have r being between, okay, I hear you, bro. Bye bye. If r is between -1 and 1, in that case, that's when that's when a convergence will happen, as you saw with this guy, r, it was half, so there will be a convergence here, right? There will be a convergence here. So now that means we're going to use this formula to derive the convergence formula for infinity. Not convergence, but a sum to infinity. So you can say therefore sum to infinity is going to be a, right, into 1 minus. So now if r, right, r is between this interval, say for example r is 1/2, just like here, right? What did you notice? You notice that as n increases, as n goes to infinity, this gets closer and closer and closer to 0, closer to 0. So if we talk, we would then say as n increases, as we go to infinity, this whole thing becomes 0. So this whole thing becomes 0, right? Yeah. And then here you'll have 1 minus r, right? So with that being said, we have the formula, right? We have the formula for something negative infinity. It is a divided by 1 minus r, because this gentleman here approaches 0, right? The gentleman approaches 0. So cool, let's cook. Let us cook. Yeah. So now this is the formula we're going to use for sum to infinity, right? But remember also, we use this formula only and only if r is between this interval. This interval. Yeah, so if you happen to have an r that is between there, then you can evaluate the sum. For example, here, if we evaluate the sum, I would say sum to infinity will be a, which is 1/2, right, divided by 1 minus 1/2, right? And the answer is going to be 1/2 divided by, here I'm going to get 1/2, right? And that is just 1, right? Yeah, so you'll realize that for this one, the answer is 1, right? The answer is 1. You can, let's make an example, right? Oh, I'm gonna show you, right? We are starting from 1 and we have 2 to the power of okay, alpha x, right? Let me see, 5, right? The sum to the first 5, they give us 0.9. Let me see, 50. 50, I'm getting 1, and 100 or 10,001. We increase this value as big as possible, right? Oh my, it's still loading. Maybe the number is too big. Yeah, let's see. The number is too big. Okay, it's 1. Yeah, bro, it doesn't matter. We're getting 1. Yeah, we increase, we get 1 again. I just added another 0. It's a million. After this thing loads, it should be 1. All right, so that's what we are getting here, that the value, like, we are going to approach 1 as n increases, right? So that's just it. Let's do these examples now. Let's do these examples. They're like, what value does this guy approaches as n tends to infinity, right? So first thing first, we have to check, is this a geometric? Okay, I don't know. I don't trust that it is, but because I don't know, I need to check. So I'm gonna check. So this is n equals to 1, and this is tn, right? 1, 2, 3, 4. I don't need so many values. So let me just 2 over 5 to power of, right? So 1 is 2 over 5. If I make it 2, that's 4 over 5 over 25. Let's make it 3. We're getting 8 over 120, 125. So now let me do this. T3 over T2. This is how I test that a series, a sequence is a geometric or not, right? So 125. No. 8 over 125 divided by 4 over 25. So 8 over 125 divided by 4 over 25. Look, I'm getting the value 2 over 5. Now let me test with T2 over T1, right? So T2, that is 4 over 25, right? And then divide by 2 over 5, which is, and I'm getting 2 over 5, right? So therefore it is a geometric. So all my concerns have been settled. This is a geometric. So now I just have to determine the sum, right? And I'm seeing that R, right? R equals to 2 over 5, right? Which is, and it is between -1, right? 2 over 5 and 1, right? So we're good. So now, therefore, I would then say, therefore, s to infinity is going to be a 1 minus r. A is 2 over 5 divided by 1 minus 2 over 5, right? So 2 over 5. 2 over 5, it's just 0 0.4. So let me say 0 0.4 divided by 1 minus 0 0.4. Yo. And I went a man. Okay. And the answer is 2 over 3, right? Or 0 0.67, right? That's the value that we are approaching. Yeah, that is cool. Let's see. Find the sum to infinity. Yay, find the sum to infinity of a geometric. Okay, so you have this other geometric, right? And delete. Cool. So this one, it's 3, 1, 1 over 3, 1 over 9, and it continues. I mean, yeah. Continue. So I'm just testing here. 1, 2, 3, 4. I just want to see T4 over T3, 1 over 9 divided by 1 over 3. That's going to be 1 over 9 multiplied by 3, which is 3 over 9, which is 1 over 3, right? T3 over T2, that is 1 over 3 divided by 1, which is 1 over 3, right? I mean, yeah, I'm already saying therefore R is equals to 1 over 3, and it's between -1 and 1, so I am good, right? I am good, and I have my value A, right? So I am good. So now I then say therefore sum to infinity is gonna be almost there. It's gonna be come on. Okay, A 1 minus r. A is 3 divided by 1 minus 1 over 3. I'm guessing it's gonna be 3 point something, if not 4, or maybe 2 point something. 1 minus 1 over 3. Right, and we approach 4.5, so then the sum to infinity becomes 4.5, right? And then here they say determine for which value of x, right, the geometric series converges, ne? And oh no, yeah, for which value of x is this series converging, right? So let's do this. This is n equals to 1 equals to 2 equals to 3, right? So yeah, then let me say t3 divided by t2, right? That is 2 over 9 x plus 1 squared divided by, in fact, bro, that's a lot. Let me use t2 over t1. Yeah. I don't know if I will be forced to go back. X plus 1 over 2, right? So let me say divided by 2, which is gonna change to multiplying by 1 over 2, because then 2, right? And then this 2 divides this 2, and then I have x plus 1 over 3, right? So this is my r, and the reason I'm already concluding that this is r is because they told me that what did they tell me? They told me that this is a geometric series, ne? So we're just trying to find the values of x at which this whole thing is going to converge. So for convergence to happen, we know that r must be between -1 and 1, right? And therefore we know what r is, ne? So it's x plus 1 over 3, 1, 1, right? So now I'm gonna multiply, -1. I'm gonna multiply everything by 3. I have -3, I have x plus 1, I have 3, and now I transpose 1, so I'm gonna have -3 minus 1, 3 minus 1, right? And therefore the answer would be -4x 2. So if x is anything between -4 and 2, then I have I'm gonna have a converging series, ne? Yeah, so long as my x is between -4 and 2, then I have a converging series. Yeah, no, doing it by trying to do t3 over t2 was just gonna be a lot of work. But yeah, always choose the easiest way out. Yeah. Cool. Let me see the sum to infinity of a geometric C. Cool. Okay, let me do this now. I need to go somewhere very fast. So on the next video, which is going to be the exam video, right, I'm gonna start with these 2 questions, and then we go do our exam papers. Yeah, I need to rush. But yeah, cheers guys.